Hello, good day viewers. In this tutorial, we are going to find a solution to this nice complex problem. We are given that if the modulus of z plus z is equal to 3 plus I, we are asked to find the value of the modulus of z. One thing you should know before you start solving this problem is that we are not looking for z modulus as a subject here, rather a value. And you know that absolute value of z is a real number, while z itself is said to be a complex number. All right, let's get started. Let's start with something general. Remember that z is given as a plus bi, right? This is the general form. But if you are looking for the modulus, z modulus, it is equal to what? The square root of the real part squared, and the real part is a, so we have a squared, plus the imaginary part, which is just the coefficient of I, we have b squared. So this is the modulus of z, which is a real number. Now let us substitute this and this into this equation. So from our main equation, we have the modulus of z to be this. We have the square root of a squared plus b squared. Then z itself, which is what? A plus bi. This is equal to 3 plus I. Remember I told you this is a real number, right? So we can take it to the other side. We have a plus bi to the left, and this is equal to 3 as a real number minus another real number minus the square root of a squared plus b squared. Then we have plus I. Now by relating the left to the right hand side, you can see to the left hand side we have real part and the imaginary part. And the right hand side we also have real part. This is the real part, while this is the imaginary part. So how can we relate them? It implies that bi must be equal to I, right? Therefore, bi is equal to I, which implies that b is equal to 1. So we have just obtained the value of b to be equal to 1. Now let us find the value of a before we plug them back into this to find the z modulus. All right. Then it implies that a is equal to 3 minus the square root of a squared plus b squared, right? So we have a to be equal to 3 minus the square root of a squared plus b squared. Now let us make this the subject. The square root of a squared plus b squared is equal to 3 minus a, right? So from here we can square both sides. If you square this, you have to square the other side just to eliminate the square root. To the left hand side we have a squared plus b squared, right? And this is equal to, we have binomial term squared. You take the first term, 3, you square that, you have 9. Then 2 multiplied by this multiplied by this. 2 multiplied by 3 is 6, and 6 multiplied by negative a, we have negative 6a. Then the second term squared, negative a squared, will give us positive a squared. Can you see we have a squared here, we have a squared to the other side, so they will cancel. What do we have? We have b squared equal to 9 minus 6a, right? And I can bring this one to the left and take this one to the other side. We have 6a. As 6a crosses over, it becomes positive. This is equal to 9 minus b squared. But remember that the value of b is equal to 1. So we have 6a equal to 9 minus 1, which is equal to 8, right? Because 1 squared is 1. So therefore, a is equal to 8 divided by 6 if you divide both sides by the coefficient of a. And to the lowest term, you can see that a is equal to what? 4 divided by 3. Now that we have values of a and b, we can simply plug them back into this equation to find z modulus. Let us do that. All right, so therefore this will be equal to the square root of a squared, which is 4 divided by 3 all squared, right? Then plus b squared, which is 1 squared. 4 squared is 16, 3 squared is 9, so this will be equal to the square root of 16 divided by 9 plus 1, but 1 can also be written as 9 divided by 9, right? So since we have common denominators, we can add the numerators. So this will be equal to the square root of 25 divided by 9. And you know square root of 25 is 5 and square root of 9 is 3. Finally, you can see that z modulus, which we are looking for, is equal to 5 divided by 3. And this is just the solution to this problem. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.